In this video, I am going to talk about confidence interval for a proportion. Within that, we will look at margin of error and other related terms using an example. We'll be using formula, calculator, and Excel to do the calculations whenever applicable. Let me define confidence interval for proportion. It is a range of values obtained from a sample where the true population proportion is assumed to fall with a certain confidence level. Let's look at a quick example here. Of course, there is a lot of work involved to find a confidence interval. Here I have this example just to give an idea of what we will be talking about in this video. Here, 95% confidence interval for proportion of high school graduates in the town of Mando is 0.63 to 0.81. This means we can be 95% confident that the true proportion of high school graduates in a town is between 0.63 and 0.81. And in terms of percentage, we can be 95% confident that the true percentage of high school graduates in a town is between 63% and 81%. Let's look at this example here. In a random sample of 80 toddlers in a town, 36 go to Oroma Kids Zone preschool. Find the 95% confidence interval for the proportion of toddlers from the town going to this preschool. Here, we will be finding all these. First, let's identify what population and sample are. In general, population includes everyone from which we draw a sample. So in this case, population of interest is each and every toddler in the town, and sample is a smaller group taken from the population that we survey. So in this case, sample is the randomly selected toddlers. That is randomly selected 80 toddlers. Next, sample size. Sample size is number of subjects in the sample. We denote this by n. So in this case, we have 80 toddlers, therefore n equals to 80. Next, we have sample proportion. It is basically the proportion of successes in the sample. In this case, 36 out of 80 go to this particular preschool. So here, x is 36 and n is 80. Then the sample proportion, p hat, equals to x over n. Our x is 36 and our n is 80. So when we divide 36 by 80, we get 0.45. Next is confidence level, and it is given to be 95% or 0.95. And alpha is 1 minus confidence level. So that will be 1 minus 0.95, which is equal to 0.05. Now alpha by 2 is half of 0.05. That means 0.05 by 2, which is equals to 0.025. This value 0.025 we will use to find critical value next. Next is critical value. It depends on alpha by 2, so critical value is the z-score, so that the area at the tail is alpha by 2. So let me label it here on this graph. So we know confidence level is 0.95. So let me write that down here. So this is confidence level, and our alpha is 0.05. But these tails, this one and this one are all alpha by 2. So therefore, our alpha by 2 is 0.025. So this tail here is 0.025, and similarly, this tail here is 0.025. So basically, this is alpha by 2. And Same thing with this one. This one is also alpha by 2. So here we need to find this value. For that, we can either use table or calculator or Excel. So let me show you how to find this value here using calculator first. So for that, let me pull up my calculator up on the screen. Now punch second, then distribution. Then we'll be using inverse norm function here. So use this arrow key to go to number 3, then hit enter. So calculator takes area to the left. So if you look at this diagram here, area to the left is from, since we are trying to find this point here, our area to the left is 0.95 plus 0.025. So that is 0.975. So let's put that here, 0.975. Then our mean is 0 and the standard deviation is 1. Then hit enter and hit enter. So this is the number that we got for z-score. For that, we can write 1.96. So let me write that down here so that this point here is 1.96. So now let me show you how to find this point here again using Excel. So for that, let me pull up my Excel up on the screen. Now click on any of the empty cell here. So then type in equals, then type in norm.inv, and calculator also takes area to the left. So here let me move my Excel little bit. So here area to the left is 0.95 plus 0.025. So that is 0.975, 0.975. Our mean is 0 and our standard deviation is 1. Then close your parenthesis, then hit enter. And we got this value here for this point on this diagram. So this is exactly what we got using the calculator also. Now let me show you how to find this value here using table. Since we know area here is 0.975, we can find critical value from the table. So for that, let me pull up my table on this screen. Here we will try to find 0.975 among these tiny 4 decimal place numbers. The number close to 0.975 is this one here, 0.9750. And now we'll be looking at the corresponding z-score for this number, so which is 1.96. Therefore, the critical value is 1.96, and that is exactly what we found using calculator and also Excel. Next, we find margin of error, and this is the formula for margin of error. Now, let's plug in the values that we have for z alpha by 2 for p hat in this formula and calculate margin of error. So here we have z alpha by 2 is 1.96 and p hat is 0.45, and we also need n, which is 80. So on plugging these values here, we get z alpha by 2 is 1.96. Square root, our p hat is 0.45. 0.45. 1 minus 0.45 over 80. Now, once we have this formula set up, you can enter this formula in your calculator and get answer. This whole thing is approximately equal to 0.11, which is E, that is margin of error. Finally, we can calculate the confidence interval. It is simply p hat plus minus margin of error. This E is margin of error. So let's plug in the values. So this becomes our p hat is 0.45 plus minus our E is 0.11. Now when you do 0.45 minus 0.11, you get 0.34 And when you add 0.45 plus 0.11, you get 0.56. We generally write this on interval using parentheses. Other way of writing the confidence interval is 0.34 and 0.559. Basically, we can write confidence interval in three different forms. So this one here, this one, and this one. Now let me show you how to find this confidence interval using calculator. So for that, let me pull up my calculator up on the screen. Now go to stat, then go to test, then use this arrow key to go all the way down where you'll see this one, A1 prop Z interval. So we'll be selecting that, then hit enter. For X, our X here is 36, so that's what we'll enter. Our N here is 80, so that's what we'll enter for N, and our C label is 0.95. Come down here, then hit enter. This is the confidence interval here, and this is exactly what we got using formula also. Finally, we have the interpretation. Based on the calculation here, we can be 95% confident that the true proportion of toddlers in the town going to Aroma Kids Zone preschool is between 0.34 and 0.56. And we can also express this in terms of percentage like this one here. Thank you for watching. We hope this video was helpful. Please like and subscribe our channel. We will be bringing more and more videos on variety of topics.